All right, so this worksheet, RNPPF, is about using some financial functions in Excel. So we're going to learn how to type things in Excel, but also how we can do this, do some of this by hand, right? Also, and we're going to learn about what's called an amortization schedule. So what I want to pay attention to now is if we consider the equation that we've seen before, like P equals P naught times 1 plus R raised to the T power, right? Then we can think of P as a future value, right? So P equals future value, P naught as present value. I can think of R as my periodic rate, right? And if R is in terms of periodic rate, then T would be the number of periods. Right? So we could rewrite that equation as the following, right? So we could say future value equals present value times 1 plus rate raised to the number of periods, NPER. Right? So I was just using each of these pieces. Right? So we also have this payment function, which I didn't consider, but we're gonna look at this in a moment, right? So essentially, the idea is if I put some money in an account, right? How much money I start with is the present value, right? How much is it worth now? And then future values, how much do I want it to be worth in the future, right? After we apply the interest and so forth, right? The payment is how much you're putting in the account each time, right? The number of periods, kind of speaks for itself, and the rate will be provided, right? So in Excel, the rate, we always want the periodic rate, right? So you can see here. So the rate equals a periodic rate. So if we're given an APR, or we're just given a percent, you should assume that's the APR. Then we need to divide that by the number of periods in 1 year, right, to get the periodic rate. Also, this might be a little difficult to think about, but we have to think about if my money should be positive or negative, right? So anytime that we're going to send money to the bank, we consider that a negative, right? And also we need to assume that all payments are made at the end of each period, right? So those are some key things when working with Excel, right? So we want to write down the function as we would type in Excel. Another thing to note is when we type things into Excel, this order always remains true. So this is an acronym to help us remember the order, right? So Rover needs poopy paper fast, right? So it seems really silly, which it is, but that's an acronym that the author is suggesting to use to remember the order of the inputs for Excel, right? So if I want to find the monthly payment, right, what function we want to use is the payment function, right? Because that's what I want to be the output, right? So we would use equals PMT, and then as I was saying, this order, right? So let me erase a little bit up here, right? So I'm going to highlight this in green. So these things always stay in order, right? So the first thing I need is the rate, right? So Rover, right? Rate. I need to enter this. And then I need to put in the number of periods. So needs, number of periods. And then we have poopy or payment, right? But that's what we're trying to figure out. So I skip over that, right? Because that's the output I'm trying to get, right? So then I would have present value and then future value. So there's always going to be 4 things in the parentheses here, and they're always in this order, right? So whatever function you're using, you just skip over the one. So like since we're doing the payment function, you can cross that out, and these keep the same order, right? Just skipping over that guy, right? And when we work in Excel, when we're typing, it'll prompt us for these things, right? All right. So let's look at how we would type this in, right? So we would do equals PMT. So the rate, remember, so we're given 8.75%, but I want this to be a periodic rate, right? So I need to do 8.75% divided by 12, right? That's my input for the rate. So we can input it like this using operations, right? You could and if you didn't want to put the percent symbol, you could put 0.0875, right, in place of the percent symbol. So it just depends on if you want to put the percent in percent form or decimal form. That's up to you, right? So in other words, this is my rate. So then a number of periods that we would input. So we want 5 years, right? And this is monthly. So the number of periods would be 5 years times 12. Right? Because there's 12 months in a year. And then next, we would enter in the amount or the present value, right, or the amount of the loan, which is $23,000. And this is really important. You know, we do not want to put a comma here. If you put a comma here, Excel will think the present value is only 23, and then look to the right to be the rest, right, to be the future value. So commas separate these items, so we do not want to use a comma, right? If you put in a bigger number than 1,000, right? So that's real important. No comma there, right? So now I have comma, and notice I put it as positive, right? It's positive because the bank is giving me $23,000, right? That's like a deposit to me. I'm given this money, and then I can use that money to buy my car, right? And then the future value, right? So the future value of this loan that I want it to be is 0, right? I want the future value to be 0 because I want the loan to be paid off in the future, right? So if I input this function in Excel, it will calculate my payment, right? All right. So number 2, the question is, what's the APR we will need to guarantee yourself an annual payment of $60,000 for 25 years if you have $1.2 million in the bank and you anticipate having nothing left at the end of 25 years, right? All right, so here we're looking for APR. So if I use the function equals rate, this will give back the periodic rate, right? But in this case, my period is years, right? Because it's an annual payment. So since my period is years, this is also equal to the APR, right? Because it's not a monthly payment; it's an annual payment. So so this periodic rate would also be equal to the APR. So I don't have to worry about working with this. If this was a monthly payment, I would have to use this rate function to figure out the periodic rate and then multiply by 12, right? Because there would be because I'm doing the opposite, right? I know the periodic rate, and if I know there's 12 periods then in a year, then if I took 12 times the periodic rate, then I would get the annual percentage rate, right? So what I'm saying is typically, so let's say we have a scenario where our payment is monthly, right? Our period is monthly, right? Then to get the periodic rate, I would have to take the APR, the annual percentage rate, divided by 12, right, to get that. So this function is going to give me this guy, right? This rate function will return this. So if I wanted to find the APR in the end, I would have to take 12 times the periodic rate. Oops. Realize I swapped the E and the R. Right, periodic. There we go. So we would take 12 times the periodic rate to get the APR, right? Because that's what we're asked to find. So you have to pay attention to that, right? But in this case, I don't have to worry about that because the number of periods in 1 year is just 1, right? Right, so we can just proceed and plug this in. So we have rate. So the next, the next part of the function, right? So you want to remember this order, right? So if this is helpful, right? We're using the rate function, right? So cross that out, and then we need everything in this order. So the first thing we need is the number of periods. So there's 25 years, and we do 1 period per year, so there's only 25 periods total, right? So we would have 25 periods. Then the next would be my PMT, my payment. So my payment would be $60,000, right? Because I'm getting $60,000. And then next would be my present value. So my current present value is negative 1.2 million, right? So remember, no commas for in the number. So we got 1, 2, then 1, 2, 3, right? And then the future value that I want nothing left at the end, so 0, right? So if I enter this Excel function in, it will return the periodic rate, which is also the APR in this case, right? So that answers the question. All right, so number 3 says, how much money will you end up if you make $650 monthly payments to your retirement account, which earns 11.3% for 36 years? Right? So how much money will we end up with? That's asking for the future value. So we'd have equals future value, and then I would put in the rate. So we want the periodic rate. So I would take 11.3% divided by 12, right? Because this is monthly, right? So a lot of things that we're dealing with financials work with monthly, but they may not be monthly, right? So you just have to pay attention to that, right? So since it's monthly, we're going to divide that by 12 because there's 12 periods in 1 year. And then we need to look at how many periods would I have, right? So I'm doing 36 years, but I have 12 months per year, right? So 36 times 12 gives me the number of periods per year. Next would be the payment, right? So my payment would be negative 650, right? This money is I'm being put into the account, so it's a negative, right? This would be like taken out of my check, right? So to me, that's a negative spend, right? And then my present value that my account would be 0, right? So we're assuming that I started with $0 in the account and made 650 monthly payments, right? So then if I put this into Excel, this would return how much money we would end up having in the end, right? And we're going to work with plugging this in Excel in a moment, right? We're going to build an amortization table together, right, and using some of these functions. But if you'd like, you could pause the video here and plug these into Excel and see you could actually find what these values are for the first 3 problems, right? So number 4 has 4 parts, and we're going to do this without Excel, right? We can definitely use a calculator, but we want to try to solve them using the equation that I had written above, right? All right. So remember, we have future value equals present value times 1 plus my rate raised to the number of periods, right? NPER. So I'm trying to figure out the future value, right? So that's going to be my variable. My present value, so we need to write on this, right? So Rover needs paper, poopy paper fast, right? So this is my rate, right? 5%. So my present, one thing, it might be difficult to remember which P is what, but an easy way to remember it is your present value and your future value go side by side, right? So we have Rover needs poopy paper fast, right? So my present value and future value are side by side, right? So I have, so my present value would be this part, right? So this is what, 1, 2, 3, 4 zeros, so 10,000, right? So this would be 10,000 times 1 plus, my rate is 5%, right? So 0.05. And then the number of periods would be 2, So we could easily plug this into our calculator. Right, so if I take 10,000 times 1.05, and this would be to the second power, we get a future value of $11,025, right? $11,025. Right, so this is growing exponentially, right? So we're using the exponential form, right? So here would be the money in the account, right? So then if you turn the page, go to the next page, part B. Here we're trying to find the number of periods, right? So again, we have future value equals present value times 1 plus rate times the number of periods, right? So since I'm using the NPER function, I'm trying to solve for this guy, the exponent, right? So we're going to have to end up using logs, right? And instead of writing NPER each time, I'm just going to denote this with the variable n, right? So it'd be easier to manage instead of writing 4 capital letters down for my variable, right? So I'm going to denote this by n. So if we plug in each value, right? So remember, rover and then needs we're skipping because it's out here. So needs and then poopy, paper, fast, right? So we have my rate, my payment, my present value, and my future value, right? So my payment here is 0. And before, my payment was also 0, right? And in C, you'll note that my payment is also 0. So with these examples, when the payment is 0, we can use this equation, right? We're not adding anymore. We're just putting some money in and seeing what happens, right? In part D, our payment will not be 0, and we'll see how we have to do that, right? Using a table to be able to do that. All right, so let's plug in what we know. So the future value is 583.2. My present value is 500. So note that it says negative 500, right? So this tells Excel if it's money coming in or out. But when we're working with this with the equation, you're just going to put in the absolute value of those. Right, so we can just use 500. So then we'd have 1 plus my rate, which is 0.08, right, 8%, and then to the nth power, right? So I'm trying to solve for n. So first of all, I can divide both sides by 500. So if I take 583.2 divided by 500, you get 1.1664 equals 1, and I'm just going to go ahead and add those together, right? 1 plus 0.08 is simply just 1.08 raised to the nth power, right? So then to solve this, I would take we need to take the log of both sides, right? So I'll take the natural log of both sides. And then the reason why we take the natural log of both sides is so that way I can get this exponent out of the get this n out of the exponent, right? So I can use properties of logs to rewrite this as, and just ignore this for now, right? I'm just going to continue on below. We would have the natural log of 1.1664 equals n times the natural log of 1.08, right? Using properties of logs. So this exponent can come out in front as a factor, right? That's the property of logs. So then now I can divide both sides by the natural log of 1.08. And this is equal to n, right? So if I take the natural log of 1.1664 and then divide it by the natural log of 1.08, right? Notice I closed my parenthesis there before I hit divide, right? It's real important. And then hit enter. We get 2, right? So n is equal to 2, right? So the number of periods are 2 periods here, right? So we got that. All right, so I can erase this so I can work on part C. All right, so here I'm trying to solve for the rate, right? So in other words, I'm trying to solve for R, right? So Rover is first, right? So N, and then we have PPF, right? RNPPF is the acronym. So 2 is the number of periods, my payment is 0, my present value is negative 1,000, and my future value is 1210, right? $1,210. So plugging this into the equation I've been working with, I would have future value, which is 1210, equals my present value of 1,000 times 1 plus R, right, raised to the number of periods, which is 2, right? So this is the equation that we have. So we need to solve for R, right? So I can divide both sides by 1,000. So we'd have 1.21 equals 1 plus R squared, right? So then to get rid of the square, I need to take the square root of both sides. So we are left with 1 plus R equals the square root of 1.21. So we subtract 1 from both sides, and R is equal to the square root of 1.21 and then minus 1, right? So we can certainly find this. So we take the square root of 1.21. Then I'm going to hit the right arrow to get out of the radical, and then minus 1. Right? Or if you have an older software update or different calculator, you just simply need to close your parenthesis, right, before you do minus 1. So here we get 0.1. 0.1, which is 10%. Right? So my my periodic rate here is 10%. Right? All right, so with part D, we're given a table, prompted with a table, because we have to fill this out a little differently, or think about this a little differently. What's different now is I have a payment, right? So this is R, P, P, and then we would have F, which would be which is out front, right? The function. So here is my payment. So my payment is not 0 now. So now I have to factor in this payment and how that's going to change things, right? So period 0, right, I would have just my present value. So my present value, right, would be $500. So that means I'm starting $500 in the account, right? And there's no interest gaining in period 0, right? We haven't started doing anything. So then at the end of period 1, though, this $500 I put in is going to gain interest, right? And it gains 4% interest. So the multiplier for 4% interest gaining is 1.04, right? 1 plus R. So we would have 500 times 1.04, right, to the first power. Let me see if I can make this a little bigger. All right. So 500 times 1.04 to the first power. And then I will be having a payment here, right? My payment is $1,000, right, from above. So I'm going to put in a $1,000 payment, right, at the end of period 1. But this will not gain interest, right, this first month, right? So if we look at period 2, this present value is going to gain another bunch of interest. So this we multiply by another 1.04, or in other words, increase my exponent by 1, right? So this would be 500 times 1.04 squared. And then payment 1, that's going to gain interest. So I'm going to have 1,000 times 1.04, right? Just one factor, because we're getting just 1 month of interest. One period of interest, right? It could be months, but it is not specified months, right? So I'm using months to give more context, but it's actually not defined what the periods are, right? So if we pretend our periods are months, this may be helpful, right? So then I'm going to have a second payment in period 2, right, of $1,000. But again, this payment doesn't gain any interest the month that it's paid, right? Because we pay it at the end of the month, right, if you will, the end of the period. So then now we move on to period 3 and see what happens, right? So this initial $500 is going to be in there for a total of 3 periods, right? So we have 1.04 to the third, right, gaining interest. The first payment will now be 1,000 times 1.04 squared, right? Payment 2 will gain 1 month of interest, so it'll be 1,000 times 1.04. And then we will put in another $1,000 payment, right, in payment 3. So then the future value is going to be the sum of all these, right? So the future value equals the sum, right? We need to add all these up, right? Add all these, right? So if we add these up, this will be the future value. So if you plug that in your calculator, you should get $3,684.03, right? So this is the future value of my loan, right? So the difference here is we have to factor in the interest earned from the present value and also each payment, right? So it makes it a little more complicated to figure out that future value when the payment is not 0, right? So this table helps model that, right? So you can imagine if we were doing this for, I don't know, like 50 periods, this would be a very long process, right? So having Excel handy will be very useful, right? All right. So I'm going to now close this worksheet and open up Excel. So if you need to print this worksheet out or whatnot, please do so. It'll be much easier to reference, right, with just Excel open, right? Because I won't be able to see what's going on. All right, so let me zoom in here. And let me fill. So I'm going to try to mimic this printout, right, the best that I can. So in A1 we have principal. All right, let me move this. All right, so we have principal, and then we have 150,000 here, and then we have APR, and then term, and then here we have typed in years for the units. So this is 30 years and 0.06, right? 6% interest. So I'm going to format these to look similar in the table. So see, they use like, if you have the color version, they use like a light purple. So maybe that's too dark. I'm just going to do this light green, right? The color doesn't really make a difference, right? But we need to fill in so they filled in a color here. And then when you fill in color, it makes it a lot nicer if you add borders back into that. So that way we can see where those lines are better, so it doesn't make it all solid. The principal is formatted in the accounting format, but it does have 0 decimal spots, right? So I can use this to decrease my decimals. The APR is formatted as a %. So remember, when we do the formatting, it doesn't change the value of the number, it simply changes how it looks for us, right? But the Excel document did have 2 decimal places, right, for the %. So that's perfectly fine if you want to do that, right? So then cell A5, we had month, and then beginning, balance, and then monthly payment, and then interest payment, and then ending balance, right? and all of these, I'm just going to do this one. We want to wrap text, and then I can just go to Format Painter and highlight all of these, and it'll copy the same type of settings, right? And I also want to do all borders, right? So I have that filled in similar to how that's charted, right? And then we have month 1, and then equals, and then I'm going to use a formula in Excel, right, to add 1 each time, because we need to go all the way down to 360, right, months. So that's in row 365. So I need to drag this all the way down to row 365, and that gives me 360, right? So an amortization table, right? So actually we can pull this up in the text if you'd like. So let me just open up the EText. So this chapter, terms are pretty important, right? So if you're not familiar with the term, you know, just in the EText, there's a search bar up here, right, where I can type in. So if I want to type in like amortization, right, then these are 2 pages that this word pops up in the text, right? So if I double click on this, we have where it says amortization schedule. So here, if you click on amortized loan, right, we can understand what that is. So an amortized loan is a loan that has a set length of time to pay back and a set schedule for when fixed regular payments are to be made, right? So in this worksheet, what's given is the following shows an amortization schedule for a 30-year mortgage on an initial loan of $200,000 at 6% APR, right? Oh, I noticed that there must be a typo in this worksheet. So it says 200,000 above, right? So let me go back to the worksheet. So what I'm noticing is that this says 200,000, this says 150,000, right? So that's a typo. Those 2 things should match, right? So I'm just going to go with the 150,000. So above here, just cross that out, and we're going to go with 150,000, right? So 150,000, this number should go here, right? So we're doing a $150,000 loan, 30 years, 30-year mortgage. So going back to this, so a mortgage is an example of an amortized loan, right? We have a set length of time to pay back. So when you get a mortgage, you know, you tell the bank, do you want a 15-year loan, a 30-year loan? Those are the most common, right? So you agree on a set amount of time that you absolutely have the loan paid off, right? And then you have a set schedule, so you have regular payments, right? So the same payment gets paid every month, right? If you have a fixed loan, right? So that's an amortized loan. Right, so then what we're doing is calculating the amortization schedule, or sometimes it's called amortization table, right? So this lists all of the information each period, right, each month. It'll tell us what's the beginning balance of any given month, how much payment should we make, how much is going to the interest, and then what's my ending balance, right? I notice here I made an error. This should be in this column, and I forgot to type in principal payment. Right there. So fix that if you need to. Right. So I skipped over that when I was typing that in. Right. All right. So first off, we need to type in. So this is actually answer number 5. Right. What formula should be in B6, the beginning balance? So we should have equals B1, right? So that's my beginning balance, 150,000. And then the answer to number 6, right? So on the worksheet, what's the formula we put in cell C6? So to calculate the monthly payment, we can use the payment function, right? So equals PMT, right? And notice Excel prompts up with the function and tells us what it does, right? So I can double click on that to prompt it. And here is the order, right? So I first type in the rate, But remember, this is periodic rate. So my annual rate is 6%. And eventually I'm going to want to pull these formulas down, right? So if you think about this for a moment, you'll realize we need to lock that in, right? So we should have $B, $2, right? And then since this is an annual rate and I'm doing monthly payment, I need to divide this by 12, right? So that would represent my periodic rate. And then next, I need to calculate my number of periods, right? So my number of periods would be 30 years, right? And again, I'm going to pull this down. I don't want that box to move, so I need to lock that in. So 30 years, and I'm doing monthly, so I would multiply that by 12, right? Then I would have comma. And then my present value of my loan would be cell B1, right? And again, I don't want this to change when I pull down, so I need to lock that in. And then comma, and then my future value will be 0, right? Because I want to pay it off. I want the loan to have $0 balance, right? So if I hit enter, I calculate the payment, right? And notice it's red and in parentheses, so this is showing a negative value, right? As currency. So and it makes sense for a monthly payment to be negative, right? Because I'm taking this $900 and giving it to the bank, right, to make a payment. So that's negative money for me, right? So then we need to look at calculate the interest payment, right? So this would actually be number 7. So the interest payment would be taking the beginning balance, right? So, when I pull this down, I'm going to want that to fluctuate, right? So just take the beginning balance, B6, times, and then I need to multiply by the periodic rate. So the periodic rate would be B2, right? I'm going to want to lock this in because I don't want that to pull down when I pull down, and then divided by 12, right? So if I hit enter, we get $750. So the first month, $750 of my payment goes just towards the interest. And then we have the principal payment, right? So this would be number 8. So what's that equation? So this would be equal to C6 plus the interest payment, right? Plus D6. So if I add those up, then I get what's left, right? So I'm actually taking off $149.33 of my balance, right? So then my ending balance would be equal to my beginning balance plus my principal payment, right? So the formula in F6 would be B6 plus E6, right? And if I hit enter, we can calculate that, right? So you can see from the screenshot we have all those values correct, right? But I can't just pull down quite yet because if you remember from what we did before when we worked on a document similar to this, is I need to connect the second period to the first period, right? So I need to connect the beginning balance to the last month ending balance, right? So I need to make that connection, and these pound signs means I need some more room here, right? And then these guys I already built where I can just drag those down, right? I already built those in a way to do that. So now that I have this beginning connected to the last month's end, I can just pull all these down, right? So I can just highlight and then double click in Excel Smart and it'll pull all the way down for me, right? Just double click in that corner and now it's all the way down, right? So some things to note, we can notice that the monthly payment is constant the entire time, right? The beginning balance does go down slow, right? Also, the amount of interest, the maximum is the first month, but the amount of interest we pay ends up decreasing, right? And since the interest payment decreases, the principal payment ends up increasing, right? So the further we go along, the less of our payment goes towards interest, right? And that makes sense because our base, like if we think about a percent, right? This is the base over here, and the principal payment would be like the amount, right? So as my base gets smaller, my amount's going to get smaller, right? If that percent stays fixed the entire time, right? So there's our amortization schedule. And we filled all of those in, right, all the way through question 10. So then if you look on page 96 in the notes, right, it says, how much interest do we pay over 30 years, right? So to figure out how much interest we pay over 30 years, we could just total the D column, right? So this is the interest. So I like to do this when I do sums, right? If you hit a bunch of equal signs in, I use that as like a equal symbol, right? When you add, right, find a sum. So then we can do sum. So I want to add up all this interest that we paid. So all of column D. Right? So this is the total amount of interest that that we paid. Right? $173,757.28. So then we're asked if we lower the APR to 5%, how does this change, right? So let me make a table over here. So we'll do total interest and then APR, right? So if I have an APR of, so originally we had APR of 6%, right? So if my APR is 6%, then I'm gonna pay $173,757.28 total, right? So let me put this in accounting format, right? So I'm working with these values here, right? So then the question becomes, well, how much interest? What if I do just 5%? How would the interest change, right? So we can figure that out. So I don't have to mess with this value at all, right? All I need to do is come up to the very top, change this 6% to 5%. And then if I scroll all the way down back to where I was, right, so this is the power of using cell referencing. Now here's the total interest I pay, right? So 139,883.68, right? So if you want, we can format those the same. So this is how much interest I pay if I do 5% loan 30 years, and this is how much interest I pay if I do 6%, right? So if you want to see the amount saved, right, we can take this minus this, right? So just dropping the APR by 1%, we end up paying saving about almost $34,000, right, over the lifetime, right? So that's a pretty significant drop, right? So every percent makes a difference, right? All right, so that's the end of this worksheet, right? So there's one more worksheet in this chapter titled Investing. So we'll explore, what's the difference between APR and APY? What about bonds? How do those work? What's the risk of having bonds? We'll look at stocks. So different ways of investing, right? So I highly recommend, following along with the worksheets. Make sure you're reading the text, and if you're not sure about a particular term, don't forget our textbook is really great, right? So you can use that search bar feature right in the top, and remember, every box that looks like this is a term. You can just click on that, and pops up pops up the definition of the term, right? All right.